Hello everyone. We are on MyoTrack team. First of all, we thank you for this opportunity to be participate in this program and this for the conference. So we are for this program we applied for this in a MyoTrack, which is a real-time motion monitoring for the hemiparesis recovery. This is mainly focusing for the hemiparesis stroke patients who have been affected. Then we have been this is mainly for the post-stroke monitoring device, which has been helpful for that. How much they have an emotions during their picking some objects, and then by picking them water bottles and kind of an objects. So this helps to be monitoring for helpful for the improvement for the patients, as well as the clinicians therapies. So first. So these are the MyoTrack team. So Dr. Samuel Kustalin, he's a faculty coordinator, and then he's an assistant professor from biomedical engineering department. And myself is Sam Smith, I'm a team lead of this MyoTrack. And Miss Dhanushree, she's a team member, and then she's the one who been take for this in a technical parts. And Mr. Darshan, who have been taking care of the IoT things like by using some things big platforms. So over to Dhanushree for the technical and working principles. Done.
Myself Dhanushree, and I'm going to explain the technical part of this MyoTrack. So we have used the MPU6050 sensor, which is a combination of accelerometer and gyroscope for measuring linear acceleration and angular velocity. When the sensor detects some movements, it is displayed in the OLED here. So we are displaying in 3 axes. Accelerometer also is in X, Y, Z axis, and myself Dhanushree, and I am going to explain the technical part of this MyoTrack. So we have used MPU6050 sensor, which is a combination of accelerometer and gyroscope. That is for linear acceleration and angular velocity. You know what is over? This is Dhanushree, and I am going to explain the technical part of the MyoTrack. Here we have used Myosa motherboard, an MPU6050 sensor, and an OLED. Here we have used MPU6050 sensor, which is a combination of accelerometer and gyroscope to measure linear acceleration and angular gyroscope. And when the sensor detects the movement, it is displayed in the OLED. It shows 3 axes X, Y, and Z for both acceleration and gyroscope, and it is given to the ThinkSpeak software. Over to Darshan.
Myself Darshan, and I'm going to explain about the IoT platform that is ThinkSpeak. So this is graph 1, that is anterior posterior linear acceleration. It shows forward and backward movement. And the second graph is about medial lateral linear acceleration. It shows about side to side movement. And the third graph is about vertical linear acceleration, and it shows about up and down movement. And the fourth graph is about roll angular velocity, and it shows about the rotation among up and down movement. And the fifth graph is about pitch angular velocity. It shows rotation along side to side. And angular velocities are sixth graph. It shows vertical axis rotation. Thank you.
For this IEEE APSCON 2026 Myosa event 4.0 IEEE Sensors Council. We did this in a motion monitoring for the hemiparesis stroke patients for the stroke rehabilitation by using the data visualizations. This is mainly helpful for the clinical assessments as well as for the therapy progress tracking in stroke-based clinical rehabilitation centers, as well as in rehabilitation stroke-based rehabilitations monitor clinicals. Thank you.